Now let's turn our attention to this intracellular compartment. You might be surprised to know that these positive charges are totally reversed. So in the intracellular compartment, you might have about 140 milliequivalents per liter of potassium, and then only about 14 milliequivalents per liter of sodium. And the negative charges are very different as well. You have a lot less chloride, you have less bicarb. Instead of those, for negative charges, you have some phosphates, which are things like HPO4 2-. You also have organic anions. So what exactly is an organic anion? Well, the fact that it's organic means that it has carbon atoms in it, and the fact that it's an anion means that there are negative charges. But let's not worry too much about the exact amounts of these things. The important thing to realize is that none of these things can easily pass between the intracellular and the extracellular space. And that's because this space is separated by a cell membrane, and the cell membrane is mostly impermeable to all these electrolytes. But what can pass easily between the intracellular and extracellular compartments is water. So water can pass pretty easily, and the reason we now know is because you have lots of little channels in the cell membranes that are called aquaporins. So aqua means like water, porin makes you think of porous. So these aquaporins are channels that allow water to pass through the membrane. And then going back to the extracellular, why did we call these two things different if they're just going to have the same concentration of all this stuff? Well, that's because there's one thing that is not the same in concentration between these two areas, and that is proteins. Because proteins are big and they have more trouble passing through these capillary walls, and so it turns out that for the most part proteins are in this intravascular compartment and not in the interstitial compartment.